Okay, this is a short video about calculations that you'll find on the AP exam in reference to atomic structure. Really, there's a lot of plug and chug. Please, it would be great if you would be sure and locate these formulae and constants on your AP equations and constant sheet. Under atomic structure, there are only two. Don't forget that you also have access to the meaning of all these units: frequency, wavelength, energy, and of course you see h, which is Planck's constant, and c, speed of light. Energy is often used to break molecular bonds, move electrons. Longest wavelength, and calculate the longest wavelength of light that would have enough energy to break the bond in a single oxygen molecule. The wavelength is 242 nanometers, and you're being asked in this problem to calculate the frequency. So let's take a look. We need to use the equation frequency as it's related to wavelength through the speed of light. So you could revise that equation, solve for frequency, but what you may not have known or be aware that it's a great idea to know how to change nanometers to meters. A very quick review. Certainly you're aware of meters, deci, centi, milli. 3 more down to micro, and then 3 more down to nano, for a total from meters to nano of 9 decimal places. Hence this conversion factor. And so that you can see that meters will cancel, nanometers will cancel, and we'll end up with the per second, which is to say hertz or cycles per second. That leads to a second question. If we know the frequency of this light, let's calculate the energy of the photon of this particular light. Let's calculate the energy. That means you'll need to access this equation. Pause. And so you can see the equation here, Planck's constant, plugged in here with units of joules second, and of course the frequency from above that we had just calculated. Bring that down. That's a per second, which will cancel with the second in joules second, ending up with a value of joules. Notice that's an incredibly tiny amount of joules, and so you're more likely to see, particularly in bond energy calculations, you're more likely to see this energy as kilojoules per mole. So if we know joules, and we'd like to know joules per mole, that sounds like requiring Avogadro's number, which, remember, is written up in the on the AP exam as per mole, but of course it's items per mole. That item can certainly be bonds. And you'll see it here. We take the very small joule value that we had, and we'll need to change that to kilojoules because there was a conversion factor change, which certainly you know, kilo down to meters, 3 decimal places, or 1,000 joules per kilojoule. And then here's Avogadro's number, bonds per mole. So joules will cancel, and we'll find out per bond how many kilojoules per mole to break the mole of bonds.